How to calculate net positive suction head available. I will explain you with an example. Let's say a vessel with pressure 3 bar with height of vessel 2 meter and 50% of that vessel is filled with water, and the vessel is at the height of 3 meter from floor, has pump connected to its bottom through pipeline. The pipeline has one 90-degree bend, one isolation wall, one strainer with pressure drop of 0.1 bar. Its length is 5 meter. The pipeline is of carbon steel with nominal diameter 3 inch and schedule 80. Calculate NPSHA at pump suction. Vessel temperature is of ambient, which is 30 degree, and flow is in the pipe is 1000 kg per hour. So if you draw it pictorially, this is how it looks. We have vessel, its height is 2 meter, and in this vessel the pressure is 3 bar, and vessel is at height of 3 meter, and the water filled is up to 50%, so it will be 1 meter. 100% of vessel is 2 meter, 50% will be 1 meter, and it has one elbow, one wall, one strainer. Okay, now the formula is P1, which is pressure at the pump suction minus vapor pressure at given temperature, which is 30 degrees Celsius, divided by density into gravity. This is the formula for net positive suction head available. Now, how we will find out P1? The simplest method, if you are in plant, is just put one PG at the pump suction. Sometime it will be available already. If it's not available, you can put one PG. PG means pressure gauge, where you can find out the pressure directly. If it's not available, then how you can calculate? The formula will be to calculate P1, vessel pressure, which is 3 bar, plus rho gh, density into gravity into height of this water level, which is 1 meter plus 3 meter. This height you have to consider in vertically, how like what is the height of this water from this point till this point. There will be that will be the water height. That height you have to consider, so that it will be 1 meter plus this 3 meter, 4 meter, plus friction loss. When the water is flowing, there will be loss in pipe due to pipe friction, and due to bend, due to wall, due to the strainer. We all will calculate all these things. Okay, so let's call this vapor pressure 1. Let's term this as 2, and the friction loss as 3. So vessel pressure we already have, which is 3 bar. That will be 3 lakh Pascal. Okay, so now second term, which is rho gh, which is static head developed. That will be uh, first we have to calculate height. Height of the water level is 50% of vessel is filled, so that will be 1 meter, and below that there is a the vessel is at 3 meter height, so this 3 meter plus 1 meter, which will be 4 meter. So the rho gh will be 1000 into 9.8 into 4, which is 3 lakh 39,200 Pascal. Okay, now we have to calculate friction loss. What all losses we will be having? One is loss in pipe, loss due to bend, loss due to isolation wall, which is gate wall, loss due to strainer. Okay, uh, this one is I have already made a video on how to calculate pressure drop in pipe due to friction. You can refer that, so that I will explain this little faster. So basically the formula is FLV square into rho by 2D. where F is friction factor. To calculate friction factor, you need to have Reynolds number. Okay, so the Reynolds number, if it is less than 2000, which is laminar, then we have different formula. If it is more than 4000, which is turbulent, then we have different formula. For to calculate the Reynolds number, we need velocity. To calculate velocity, we need uh, area of the pipe. To calculate area, we need inner diameter. To calculate inner diameter, it's which is not given, so we have to calculate using nominal diameter and schedule. This also I will make one more video where I can explain in clear. So in general, if you have nominal diameter and schedule, you can find out inner diameter. So once velocity is calculated, it's coming up to be 0.00426. Sorry, this is area. Velocity is basically volumetric flow by area, so that will be 0.0652 meter per second. Viscosity of water at 30 degrees Celsius is 0.00078 Pascal second. So now the Reynolds number will be rho Vd by mu. Rho is density, V is velocity, D is diameter of pipeline, and mu is viscosity, which is 6018. Since it is turbulent, for turbulent flow, the formula to calculate friction factor is this. Here epsilon is roughness of pipe. For carbon steel, roughness of pipe is 0.05 mm. So if you put all these values here, epsilon D is diameter, Re is Reynolds number. If you put all these values, we will get friction factor as 0.0367. If you put that in the pressure formula, F is 0.0367, L is 5 meter, which is given, rho is density 1000 given, where V is velocity we have calculated, 2, and D is diameter. So if you solve this, we will get P as 5.29 Pascal, and then loss due to bend. For that, the formula is P equal to K rho V square by 2. For 90-degree standard bend, K is the coefficient of pressure loss. So K is 0.721. This you can find online. For different kind of elbows, you will be having different kind of K values. It is 0.721. I have considered 8.8. So the P will be 0.8 into rho is 1000, V is velocity square by 2, which is 1.7 Pascal. Loss due to gate wall. For this also formula is same, but only K value changes. For this K is 0.15 to 0.2. I have considered 0.2. So the pressure is coming to be 0.425 Pascal. For different walls, there will be different K values, which we can find online. And pressure loss due to strainer, assume it is a 10 Pascal. I have just assumed it as a 10 Pascal. Actually, in question it is given as a 0.1 bar, but yeah, you can take 0.1 bar, which is I think 10, which is 10,000 Pascal, or you can just assume it as a. I assumed it as 10 Pascal. If the strainer is very new, it will be the pressure drop will be very less. If the strainer is filled old, it's been there for few days, then the debris will get accumulated in the strainer, and the pressure drop will be more. So the total friction loss, as we have seen here, if we add all this A, B, C, D, which we have calculated also, if we add all this, A 5.29, B 1.7, C 0.425, D 10, it will be 17.415 Pascal. So in the initial formula, which is P1 is equal to vessel pressure plus rho gh minus friction loss. So we have already got vessel pressure, which is 3 lakh, and rho g is 39,200, minus friction loss is 17.415. So the total will be 33,000, sorry, 3 lakh 39. So it is 3 lakh 39,182 actually. Just a minute.